Is the universe incorrect, or are our theoretical models? The solution, of course, is clear. These days, the James Webb Telescope has captured a whole catalog of enigmatic findings that defy accepted theories of cosmology. However, what groundbreaking insights may be gained from these impossibilities? Do we now have to acknowledge that we have been on the wrong astronomical path for decades, or are our presumptions on the age and origin of the universe still valid? Numerous intriguing advancements have been made in the past as a result of the ongoing changes in the field of cosmic investigation. Just consider our distant ancestors' perspective, who were adamant that the Earth was the center of the universe and that all other celestial bodies rotated around it. Well, you could be mistaken. Naturally, we now understand that our earthly home is only a little fragment of a vast overall picture that we have yet to fully comprehend. Nevertheless, it appears that each new finding must first get past a few internal obstacles. Do you want an example? Albert Einstein adhered so tenaciously to his conception of a rigid, unchanging universe that he included the cosmological constant to his field equation, despite Edwin Hubble's recognition that almost all observable galaxies were moving away from us. In retrospect, we may say that Einstein later acknowledged his error, referring to it as the greatest blunder of his life, and that Hubble's discovery of galaxy movements was connected to the universe's unrelenting expansion. Our official understanding is that the Big Bang, which occurred 13.8 billion years ago, marked the beginning of this expanding process, not yesterday. However, this process does not represent a massive burst into existing space, despite initial beliefs to the contrary. Matter and time also arose from this small, hot beginning point, as space itself rapidly expanded from an initial singularity. However, how are we even aware of this today? Simply put, by examining the analogous development in reverse. This makes it feasible to compute back to a point where all spatial distances equal zero and the density of matter and energy becomes unlimited. The discovery of cosmic microwave background radiation is another compelling example of the Big Bang theory's accuracy. The entire universe is filled with this nearly isotropic remnant of the period immediately following the universe's genesis. So far, so widely acknowledged. However, how do you handle findings that just don't fit the Big Bang theory and its derived conclusions? The initial galaxies were still cosmic dwarfs, according to the cosmological consensus, and the first stars were produced 200–300 million years after the Big Bang. It's understandable, after all, there wasn't enough regular matter in the universe at the time to theoretically build full-fledged galactic giants. The James Webb Telescope discovered something last year that, strictly speaking, shouldn't even exist: the impossible galaxies. This is because the universe doesn't seem to be very interested in our theoretical models. Some photos from the near-infrared camera, NIRCam, from the James Webb Telescope's early release program had been examined by astronomer Ivo Lab and his colleagues at Swinburne University of Technology in Melbourne. The pictures displayed a region of the sky close to the Big Dipper, which is often seen as a component of the universe's dawn. And sure enough, Lab quickly realized that he and his colleagues had just discovered something remarkable. I run the analysis software, and it spits out two numbers: distance, 13.1 billion years, and mass, 100 billion stars, he said, describing the initial response to the groundbreaking discovery. I nearly spat my coffee out. I was aware that we had just made the inconceivable discovery: galaxies that were both impossibly large and impossibly early. This explains why the expert used the word impossible so frequently. These galaxies would have to have originated in a method that is entirely unknown to us, or the density of stuff in the early universe would have had to be 2 to 5 times higher than what our models indicate. In either scenario, scientists are faced with a significant conundrum, because both situations call for a significant shift in how we perceive the universe. Scientists have yet to offer a convincing explanation for this unexpected finding. All that is known is that 6 galaxies with 10 billion, and in one instance, even 100 billion solar masses of stars existed 500–700 million years after the Big Bang, making them comparable to the Milky Way as it exists now. That the items are called universe breakers by the research team is not surprising given this. What was once thought to be scientifically certain, that stars in this era of the cosmos had masses up to 100 times larger than those suggested by the earlier models is now called into doubt by this revelation. Cosmology has up to now presumed that galaxies start out as tiny star and dust clouds and progressively enlarge. However, is it not possible that star affiliations can develop in other ways? The specialists are even more perplexed by this discovery. In the future, this mystery will still need to be solved. This will be crucial, as demonstrated by the James Webb Telescope's next discovery. In the same sentence, the $10 billion gadget recently added another problem to the star charts and set a new record. Researchers at the Scuola Normale Superiore in Pisa have discovered JADSGS Zone 140, the oldest galaxy yet discovered. This gravitationally bonded group of stars and other objects was generated 290 million years after the universe was created, according to the data analysis. However, the main conclusion is that it most likely took 100 million years for it to reach its current size. Speaking of scale, in this instance as well, the researchers saw a structure that already included several hundred million solar masses of stars rather than the feeble baby galaxy predicted by our present models. The question of how this could have occurred at all in the early cosmos is raised once more. Why did additional investigation reveal that the spectrum contains both hydrogen emission lines and oxygen? And how could such a big and luminous galaxy have formed in less than 300 million years? This fact, after all, suggests that before the experts studied this galaxy, a few of really big star generations had already finished their life cycles. Well, a lot of questions. But do we have any answers? Given the findings thus far, one may assume that every new Webb discovery merely serves to further engulf astronomers in their ongoing scientific predicament. However, that isn't true. Thankfully, the answers are more illuminating. There were no galaxies, stars, or other light sources during the so-called Dark Ages, which began some 380,000 years after the Big Bang. In fact, a thick mist of hydrogen gas filled the clear neutral room. The so-called reionization process, which started about 100 million years later, caused the hydrogen to become ionized and translucent once more. This process was literally conceivable and was caused by the first extremely powerful stars that knocked electrons out of the hydrogen atoms. However, this is where things become complex. For decades, there has been intense debate over the origin of the photons that gave the universe its brightness. Black hole effect was the basis for several theories, but Webb has now opened the cosmic veil and provided a peek of the light behind the scenes. In particular, a global research team has found that massive volumes of high-energy radiation were probably created by microscopic dwarf galaxies. As part of the UNCOVER study, which is being conducted with the assistance of Webb's NIRSPEC and NIRCom, the researchers located this astronomical path. But occasionally a creative method is needed to make the light of very distant galaxies visible. This method, known as the gravitational lens effect, describes how huge masses can deflect light. In essence, an item that seems to be in front of the light from a distant source, the gravitational lens influences that light. The following rule is applicable. Light rays are more deflected in the direction of the mass the closer they are to it. In the instance of the aforementioned discovery, this means that 8 galaxies that are typically invisible to the human eye were rendered visible through the lens of the galaxy cluster Abell 2744. In summary, spectroscopic study revealed that these formations release 4 times as much radiation as previously thought, although being around 100 times less luminous than the Milky Way. As a result, astronomers were happy to report that they had located the sinister photon source that used to illuminate the universe. To be clear, these 8 tiny galaxies did not ionize the cosmos and restore its transparency between 500 and 900 million years after the Big Bang. They are merely proxies that are representative. In the early cosmos, the low-mass cosmic powerhouses happened often enough to collectively alter the universe's state. Additionally, you're present in the universe often enough for us to be able to modify the subscription button state with a single click. Become a member of our community today to ensure you never miss another thrilling video from us.